Igneous, Sedimentary, and Metamorphic classification. I picked this topic because I enjoyed learning about rock classification from the in-class labs especially. This is an area that I would like to continue my education in. Classifying rocks has always been something I've been interested in, but I've never learned how to do until this class. Igneous rocks are magma solidified. All igneous rocks fall into two groups, volcanic or extrusive and plutonic or intrusive. The difference is in how fast they solidify. Intrusive rocks form below the surface and they cool slowly. This leads to large, visible, coarse grains. Extrusive rocks form at or near Earth's surface and they cool fast. This leads to a fine-grained, microscopic texture. This difference in rate of cooling leads to different textures. As well as using texture, silica content is used to classify these rocks. Felsic means light-colored, intermediate is an equal amount of light and dark, and mafic is silica poor or dark-colored. Using this information of texture and silica content, igneous rocks can be classified. For example, volcanic felsic rocks are rhyolite, and plutonic mafic rocks are gabbro. Sedimentary rocks form because of weathering and erosion of minerals near Earth's surface. Because of this, sedimentary rocks are composed of loose rock and mineral fragments, minerals precipitated out of water, and shells and organisms. Identifying sedimentary rocks begins with identifying whether it is clastic or non-clastic. Clastic consists of broken pieces of pre-existing rocks and are classified based on their size, shape, sorting, and cement. There are no obvious particles in non-clastic sedimentary rocks. They will be either chemical, formed from minerals precipitated from water, forming rocks such as rock salt and gypsum, or biochemical, formed from biological activities, or made up of plant or animal remains. Metamorphism occurs when a rock is in its already formed solid state. Rock is subjected to changing conditions of temperature and pressure associated with burial, magma, and processes at plate boundaries. Rocks may change shape, minerals may grow larger or rotate and realign, and new minerals may grow due to chemical reactions in the rock, changing the texture and composition. To classify these rocks, we first try to identify foliation. Foliation is the increased pressures and temperatures that create an alignment of minerals. As temperature and pressure increases, rocks will continue to go through a metamorphic process. Slate will become phyllite, and then schist, and finally gneiss. It can be seen how the foliation becomes more and more defined as the grain size decreases. However, not all rocks develop foliation. The metamorphism of sandstone changes the texture only, forming larger grains and quartzite. Knowing what metamorphic rock will and won't foliate will aid in their classification. I'm an art major, and it's unlikely that I do anything in my career dealing with rocks and minerals, but I've always loved rocks. I've been collecting them since I was a little kid. I can't resist. I've never known much about classifications, names of rocks, or how to identify them, however. I'm not the only person in my family who collects rocks. All my sisters do, and even my mother does. We learned it from her. My family would be for sure interested in learning this information. I've enjoyed learning about the different types of rocks and minerals in this class, and I will continue to learn so I can try to identify any rocks I find and that my family finds going forward.